Alright. How's everyone doing? Let's see if I can copy the stream link to the Discord. Alright, there we go. Officially got it sent out. We don't have anyone in yet, but that's okay. Okay, we have our first person. Alright, I'm gonna wait till we have at least like 4 or 5, and then we can get started. Unless there's a question that you just really, really want to ask. Okay, we got 2 in. We'll wait till we have like 5, and then get started. Sorry for the weird link. Thanks, Worth, for fixing that. I don't know why it happened that way. What's up, Bobby? Nice to see you in here. Ready to absorb some knowledge. I haven't done one of these in a little while, so we'll see how this goes. I got a chance to look at the number sense, the math, and the physics. I didn't get a chance to look at the calculator, so let's hope that goes smoothly. Okay, we got 6 people. Somebody suggest what the first thing you want to go over is. You don't have to have a specific question, but if there's just like one test you want to go over. I have the regional tests. It might be better to put on low latency actually. Is that gonna completely mess me up? I guess it won't let me switch. Alright, we have a vote for number sense. Let's go to number sense. Okay. Alright. Got our test here. Yeah, I looked on this test. There was actually some interesting questions on here. I took the test. I'm not entirely sure why scores were so low. I guess this first half was a little bit slow. But there is the point that I didn't take this in competition, obviously. So, let's see. What were some of the interesting ones here? We had... I forget. Oh, this is something that they like to ask nowadays. That Larry White is kind of liking is this like triple right here. Oh, he said, what'd you get? I got like a 340 something. I got to this 76, and I didn't miss that many actually. I forget. I took it a couple days ago. So if I got to there, I would have gotten, yeah, like a 348. I think I missed 3. I missed this 54 just because I forgot how to add. I didn't know how many inches were in a fathom. That's kind of a weird thing. And then I think I screwed up like number 20 estimation. But yeah, I'm just going to start looking at some of the interesting problems, and if one of you wants me to go over a specific one, then we can do that. Okay. Well, this 15, 16, 17 is something that's been coming up a little bit more often. Larry White used to ask this, and not Larry White. The test writer used to ask this on really early tests, like 1970s tests, and Larry White liked it and he brought it back. Oh, we have a taker for question 3. Oh, okay. So we have this division here. Probably like the canon way to do this is you just do long division. But when I do these, I like to split them up a little bit. So instead of thinking of 30.24 divided by 3, I think of doing it as 30 divided by 3 plus 0.24 divided by 3. This might be what you just do intuitively, but this is kind of like the pedagogical way that I like to explain it. So 30 divided by 3 gives you 10, and then 0.24 divided by 3 will just give you 0.08. And, if there's something that, I know there's a little bit of delay in the stream, so if there's something that I say that doesn't make a lot of sense, don't be afraid to text it in the chat. I know sometimes I skip steps that aren't always obvious, but I'll do my best to avoid that. You guys excited for state? Did all you guys make state? I know we have like an incoming freshman in the chat right now, in the stream. How would you approach 34 through 36? Let's see. Oh yeah, this is another one of those triples. Yeah, he really liked it on this test. So number 34, I would probably just do it like the typical way. And then you can use your answer on 34 to get 35 and 36. So be pretty careful that you don't get 34 wrong. So for 34, I'd probably subtract 8 and then add a quarter. I think that's the easiest way. So 41 minus 8 is going to give you 33, and then 33.5 plus a quarter would be 33.75. Oh yeah, the fact that it stretches over the back of the page, yeah, that's kind of annoying. I wonder if he did that on purpose. Yeah, that is kind of mean, actually, now that I think about it. Okay, and then from 34 to 35, it's the same problem, except now you're just subtracting an extra 9 and 7/8. So I would do a similar thing, subtract 10, and then add an eighth. So 33 minus 10 is 23, and then 0.75 plus an eighth would be 0.875. If you like fractions, you could make this 23 and 7/8. Oops, not 8/7. It's the good thing about doing this on a computer is you can erase. Yeah, so 23 and 7/8. If you know your fraction to decimal conversions, it's pretty much the same, but whatever you prefer. Okay, and then let's see, 36 is the same as 35, except instead of subtracting 7 3/4, you're adding 7 3/4. So that would be the same thing as to go from negative 7 3/4 to plus 7 3/4. It's like adding twice that. So you would do 23 and 7/8 plus twice that, which would be 15 and a half. Yeah, 15 and a half. I don't know why I'm thinking that's wrong. No, that's right. My brain is just struggling. Oh yeah, so 23 and 7/8 plus 15 and a half would be, you get 3/8, carry the 1, give you 39. So yeah, pretty much with these problems, obviously he started asking this after I stopped competing, but when I would take those 1970s tests, you basically just have to find what the difference is between those the current problem and the past problem. And usually that makes it significantly easier. Okay. Any other suggestions? Yeah, and then 15, 16, 17 is very similar to that. Like 30 divided by 2/5 would be 75, because it's like 30 times 5 halves. 30 divided by 2 is 15, times 5 is 75. And then here you're dividing by a number that's twice as big, so it's going to be half the size. And here you're dividing by a number, this is 1.2, or 6/5. That's 3 times as big as 2/5, so it'll be 75 divided by 3, which is 25. So just stuff like that. Let's see, what other interesting stuff was on there? It's crazy that he put this on here like twice. Usually it's only once. For the ones, I don't think there's one on this test, but it's like how many primes between two numbers? You just have primes memorized to some number. Oh, yeah, I guess. I mean, I never really sat down and memorized primes, but yeah, I kind of just have primes memorized to 100. It's, I think that's something that's worth memorizing, especially for like prime factorizing and just just in general, being able to manipulate those quickly. But yeah, I guess I have primes memorized to 100. Oh wait, question 11. The sum of the prime numbers greater than 70 and less than 80. So yeah, I would just know like 71, 73, and 79. I mean, well, like for example, none of the even numbers are going to be prime. And then like 75 is obviously divisible by 5, and then 77 is obviously divisible by 11. Yeah, and then I would just add those and get 223, I think. Yeah, 223. Oh, Worth is in the chat. Let's go. Says, hi, Aiden. Just curious, how would you estimate number 30? Let me remember what I did. Estimations are such a blur. Let's see. I'm pretty sure. Actually, I think this is what I did. I know that 2 over 15 is like 0.133 repeating. And so I said this is like 150,000. And then instead of divide by 136, I said divided by 2/15 times 1,000, which ended up being, so take 150,000 divided by 1,000 is 150 times 15 over 2. So that's like 225 divided by 2 and add a 0, so like 1120. Is that correct? 151,222 divided by 146. Oh, wow, that's actually, yeah, that's pretty close. Yeah, some of these division is the way to go. But actually knowing your like decimal to like fraction to decimal conversions can be really helpful in these estimations. Yeah, I'm pretty sure this is what I did when I took it. Yeah, and then again, there's something to be said for just being able to do estimations well, and that's just another skill. But I think you said you did 150,000 divided by 140. It's like 1,000 plus. Yeah. Let's see. Did I notice the sign change on question 32? Oh yeah. I mean, if this was just x squared minus y squared, this question would be super easy, right? Because it's just you use the multiplication x plus y times x minus y equals x squared minus y squared. But if you want x squared plus y squared, what you can do is, what you can do is x plus y squared is x squared plus 2xy. Wait, no, what did I do here? I might have just solved for x and y, honestly. Yeah, I mean, actually, this is pretty easy to just like solve for x and y. X equals 5 and y equals 1, so yeah, 26. I was thinking of a different kind of problem. Yeah, there's a kind of problem where what I said is common to see. I think it's whenever it gives you like xy equals something and like x plus y equals something, and then you can and then from there you can find like all the different like what's x minus y, for instance, by using those factoring methods. Says there was an idea x plus y squared plus x minus y. Oh yeah, that's true. I actually used that on a physics homework the other day. I should have thought of that. But yeah, so that's a good idea. But then again, like this is pretty easy to just solve. Oh yeah. Okay. For everyone that doesn't understand, that didn't get that, if you take x plus y squared and you add x minus y squared, um, you get x squared plus 2xy plus y squared plus x squared minus 2xy plus y squared. And so your 2xy's cancel, and you're left with just 2 times x squared plus y squared. And so this would be 36 plus 16, right? Your x plus y squared plus x minus y squared. We 36 plus 16, which is 52, and then divided by 2 is 26. Yeah, yeah, that's a pretty good idea. I can see that being very helpful if you have like more difficult numbers where the system isn't so obvious. Let's see. Oh yeah, I can wrote down the 2 and then realized the plus sign. That's clutch. It's that's pretty nice that it ended up being 2, like 20 something. Yeah. Then it asks for x cubed plus y cubed. Yeah, that's a different trick also. Where it asks for x cubed plus y cubed. Yeah, that's tricky. Triplet was clutch. Yeah, there were 2 of them. We were looking at that before. I don't know why I erased that. Whatever. Yeah, we were looking at the triplets before. There was 2 of them. It's a little bit mean that he like put this one on the page flip. This is a decimal. I think I erased it. Let's see. For 12, you just do 20 plus 24 minus 1. Is that how many integers? Yeah, that's what I did. I just did 20 plus 24 minus 1. Or, like, I guess technically it was 24 minus negative 20, um, but yeah, like, I get what you're getting at. But, like, in general, you would subtract them, and then since they're between, that means it's not inclusive. So, yeah, you would subtract 1. Yeah, that's the tricky part. Yeah, so if it's pretty much the rule is if it's exclusive, like if you just subtract the 2 numbers, you're always going to get 1 less than the total number of numbers. Um, and this isn't always like super intuitive, but if I tell someone like you do problems like 1 through 6 on your homework, how many problems are you going to do? And like obviously the answer is 6, but if you do 6 minus 1, you get 5. And so uh, I guess that's a way you can use to remember that. Um, if it didn't say between, would you add 1 instead? Yeah. So if you were including negative 20 and 24, then you would add 1. Um, yeah. If you ever forget, like just a general good problem solving strategy is to just like take a really simple case. So like if you want to know the number of integers between like 1 and 3 and you're excluding, well, just thinking about it, just like looking at it, there's only 1. And if you do 3 minus 1, you get 2. So you subtract 1. But then if you're including, then there's obviously 3. So you add 1. That's just like a good problem solving strategy in general. Yeah, this was 43. Let's see, how would you do 27? Divide 24 into 4 parts such that the ratio of the 4 parts is 1, 2, 3, 4. The largest part is 1. Okay, so this is saying, basically, I'm dividing 24 into, so dividing 24 into 4 parts that all share this ratio. So I don't actually know how big each of these parts are, but I do know that, like, for example, the second part is twice as big as the first part, and the third part is third part is 3 times as big as the first part. So I'm going to say that however long that bit is just x. So 24 would be x plus 2x plus 3x plus 4x, which add those all together, you get 10, so x equals 2.4. And then the largest part would be the 4x, obviously. So 4 times 2.4 is 9.6. Yep. Nothing too crazy, but it's one of those that maybe you just have to see it once and then it's clear. Let's see, 28. For some reason, dividing fractions, like dividing mixed numbers, just messes with my brain. Maybe it's because, like, in school you're taught to like make them improper, then like flip the second and multiply. But what I like to do is I just turn them both. I turn them both improper. So this would turn to 14 over 5 divided by 37 over 10. And then instead of like flipping the 37 over 10 and multiplying, I just like to divide across. So this would be like 14 over 37 divided by 1/2. And so dividing by 1/2 just is 2. So it gives 28 over 37. Okay, let's see, 13. 13. Looks like we have an explanation going on in the Discord already, which is great. I'm not telling you to stop that. Right. Okay, so there is like a general trick for this. I think I took the regular way, but I'll show the trick. The trick is basically what he did, just simplified down. So first of all, you're going to look at the differences between the numerator and the denominator, and also the whole number and the denominator. So the difference between 31 and 34 is, or maybe it's better to go the other way around. 34 minus 31 gives you 3, and 34 minus 33 gives you 1. And that's going to be the numerator of your fraction. So you get 3, and then your denominator just stays the same, 3 over 34. And then to get the whole number part of your mixed number, you just take this difference. So 31 is 3 less than 34. So I'll do 33 minus 30. Sorry, 33 minus 3, which gives me 30. Hopefully that made sense. There's a lot of practice in that Bryant Heath book on this kind of trick. There is a variation of this that's different. That'll if you're not careful about how you subtract, it'll mess you up. Because it does matter like which order you do the subtraction in. But yeah, it doesn't look like they were mean on this question. Let's see, what else? How do you do 33? Oh yeah, 33 is a good one. This is one where it's kind of just a pattern you have to recognize, and that's this is actually going to be a perfect square. The way you can tell is if you multiply these coefficients, the 4 and the 9, take the square root, multiply by 2, that you get this number right here. So this can actually be factored to 2x minus 3 squared. So 15 times 2 is 30, minus 3 is 27, which squared is 729. Yeah, that's just one you have to sort of get used to the pattern. But once you see it enough times, you get a little used to it. Lots of good questions here. This is pretty active compared to a couple streams ago. I think this is just because state is coming up. Dark Nova 924 says, I wish I did number sense. It seems fun. You should definitely do it. I mean, unless you like graduated or something. Oh, sorry. I was that was a little bit misleading. No. Okay. So if this pattern is true, no. Okay. So if the pattern I said, that just means that it's going to be a perfect square. Oh, graduating this year. Um, yeah. Okay. So if it's a perfect, the pattern just tells you that it's a perfect square. So it can be factored into like some linear something squared. The way that I got the two, like the 2x minus 3, I took the square root of 4 to get the 2, the square root of 9 to get the 3, and then this minus sign told me that this was going to be minus. And kind of like the rationale behind this, like if I take like ax plus b squared, you get a squared x squared plus 2ab plus b squared. And if you kind of like pattern match to our problem, you get that a equals 2 and b equals -3. So I'll leave it up to you to like work through the algebra and convince yourself that this is consistent. But yeah, that might have been a little misleading. It's not always 2x minus 3. Do we want to explore the back page a little bit? Did you guys get number 47? 47 with the fractions always messes people up. Maybe not this time. Maybe you guys are used to it by now. What was the farthest someone got on this test? You guys know that just off the top of your head? The double integral on 76 was a little bit annoying. Like doable, but okay, someone got to 79. Oh, Alex got to 79. 79 was so funny. I looked at it after the fact. It was like you have T and P. It's like T for triangular number, P for pentagonal number. Like what in the world? That's I was looking for a pattern. I was seeing like, well, at first I thought it was Fibonacci because there's like you have 1, 1, 3, 5. You just skip the 2. But then I saw like 12, 10, 22. I was like, okay, there's something going on here. Go over the double integral. Okay, sure. I'm not sure if there's actually like a quick way to do this, actually, but this is how you would do it just normally. There's probably a quick way to do it because this is linear, but I'm not sure. So basically, what you do is you look at the interior, and by the interior, I'm basically just like isolating this dy. So you take this integral with respect to y, and then whatever answer you get there, you take that integral with respect to x. So the integral of xy with respect to y is just 1/2 x times y squared. To evaluate individually. I'm not really sure what you mean by that. If you mean like the double integral, like if you mean like the bounds on the integral, then yeah, that's what I did. That, like I said, there's probably a quick way to do this if someone wants to type it in because this is linear, but not linear, but like linear in each term. But I don't know off the top of my head. Yeah, so you get 1/2 xy squared. Then from 3 to 2 would be 9, 5, 4. So this would be, is that just 2x? Did I do that right? No, not right. It should be 5 over 2x. If I just plug in 3, plug in 2, and subtract. And then integrating from 2 to 1 with respect to x, that's 5/4 x squared, 3, so this should have been 15 over 4. Oh, okay, it looks like we have a trick in here. You can just do integral from 1 to 2 of x dx times integral from 2 to 3 of y dy. Oh, really? Oh, wait, I guess that kind of makes sense, just like geometrically. Okay, let's see if this works. Okay, so the answer is 15 over 4. Okay, so the integral from 3 to 2 of y dy would be just 5 over 2. And then from 1 to 2 of x dx would be 3 over 2. Yeah, that is interesting. Oh, yeah, because the x is constant and you factor it out. Oh, yeah. Yeah, double integration is, it's hard to like visualize like it is with just single integration. But yeah, that makes a lot of sense. Thanks for that. Yeah. Well, anyway, that is 15 over 4. That seems like the kind of question he wouldn't ask again. I don't know. Maybe I'm wrong about that, but this seems like one that he was just like trying to have fun. Okay. What if it was integral of x minus y? Um, well, I mean, it's kind of the same process. Yeah. I would imagine you just have to bash it. The thing with like with them being multiplied is that when you have uh when you like do the integration with respect to y, x is a constant, so you can like sort of factor it out. Okay, we have a request for number 77. This is like a conics question. And honestly, the hardest part about this for me is remembering where the stupid 4p is, because I always forget. Okay, but we have x equals y squared minus 1. So we know our vertex is at 0, comma 1. By the way, standard form for a conic, or not for a conic, for a, what am I saying? For a parabola in like conic form is 4p times x minus h times y minus k squared. Wait, did I do that wrong? Wait, no, I think that's right. Okay. Oh, yeah, here we go. Okay, so this is just going to be, no, I did this wrong. That's not the center. I lied. You have to rewrite this as x plus 1 equals y squared. And so this is the same thing as, okay, so we have x plus 1 equals y squared. So our vertex of the parabola will be at negative 1 comma 0. And then from like sort of pattern matching this, you can tell that 4p is going to equal 1. And so p will be 1/4. So let's see, we're looking for the focus. So since this y squared is positive, it's going to open up to the right. So there's our negative 1, 0. And the focus is like on the quote unquote inside of the parabola. So we just move 1/4 to the right. And so I think x will just be negative 3/4. Let me double check that. Yeah, negative 3/4. Yeah. Yeah, the 4p does go on the constant side. The reason, not the reason, but the way that I remember this is that 4p is like p isn't a variable, like it's a set constant for the problem, but it doesn't have like a squared term. So I imagine that like the quote unquote linear part for 4p, right, would go on the side with the part that's linear in the either x or y variable. That's not like a super like rigorous way of remembering it, but I always forget which side it goes on. Oh, we're talking about number 80. Okay, number 80, when I worked this, there was like a very obscure piece of knowledge that I had that made this significantly easier. And that was that the log, like the log base 10 of e is like 0.45, something like that, 0.45. And so what I did here is I used like a change of base, like a change of base for the log. So instead of doing log base e of 100,000, I did log base 10 of 100,000 divided by log base 10 of e. Log base 10 of 100,000 would be 5. And then log base 10 of e, if I do like 0.45, that's the same thing as like 5 times 20 over 9, which gives you like 11.1. What is the range on this, by the way? Yeah, 1450, that's what I thought. And then so like 11 cubed, then it's like 1300 plus a little bit, so I'll say like 1400. Is that in the range? No, that's low. Oops. Yeah, it's because I'm pretty sure the log is a little bit less than that. Yeah, that's a tricky question. But I guess, yeah, 11 cubed doesn't work. That's annoying. I guess just have good intuition. I don't know a better way to do that. I imagine that's how he wants you to do it. But yeah, that's tricky with 11 cubed not being a possibility. Oh yeah, number 78. This is another one where you just have to know that this is like a certain fraction. I'm pretty sure this is. Oh, I'm losing it. 11 over 16. I'm pretty sure that's right. Oh, I hope so, because that's divisible by 11. So that would give you 480. If you missed that, that's 330 times 16 over 11. 330 over 11 is 30 times 16. Gives you 480. Yeah, so 11 over 16. So I guess it just depends on if you see that or not. But that's just typically a good thing to look for. I guess also if you maybe didn't know that it was 11 over 16, but if you subtract like 0.5, you get 0.1875, which is 3/16. It's like 8/16 plus 3/16 is 11/16. Yeah, I guess it just depends. That is a good thing to memorize though. Did everyone see the pattern on 79? It's kind of fun. Like the nature of the answer was funny. Or double it and notice it's 11 over 8. I mean, I guess you could do that, but it would be odd to double it if you didn't already know that it was 16. Same pattern as district? Oh, I didn't realize this pattern was on district. That's funny that he did that twice. Yeah, but it's like the odd terms are triangular numbers, so t is 15, and the even terms are pentagonal numbers, so p is 35. Just negative 20. Yeah, adding 0.68 and 0.0075. Yeah, it's honestly not that bad. Maybe once you get to 78, though, or not 78. Where is it? Oh yeah, 78. Maybe your brain is a little bit fried, but I don't know. That's just me. Oh, okay. So this is on district. It was just at the top. Interesting. Usually Larry's like very consistent with making super weird patterns. Maybe he's lost it a little bit. I don't know. Or maybe he was just being nice. Larry's a very nice guy. He's gonna challenge you, but he's a pretty nice guy. Did everyone go home and look up how many inches are in a fathom? I'd never memorized this before. Maybe he's been asking this like on past tests from this year. Yeah. Anyway, a fathom. Instead of memorizing inches, I just I learned after taking it that a fathom is 6 feet, and so this is basically 72 times 150, so 1080. Fathom is pretty common. Yeah, maybe this This here has been common. I don't know if I've seen that before. 47 to the 15th mod 29. Where is that? Is that on the first page? Am I looking right at it? Which question is that? Oh, right here, 64. Oh, oh yeah, how to do 72 times 150 fast? Like uh, I multiplied the 150 by 2 and divided the 72 by 2, so it just ended up being 36 times 300. Yeah, yeah. A couple people have talked about it. Okay, yeah, 47 to the 15th divided by 29. Um, yeah, this was actually a discussion a while ago. I'm trying to figure out how to tell if this is like if you take the plus or minus square root. And honestly, when I took it, I just got lucky and picked that it was minus. But I wonder if we can come up with something here. Okay, so basically, if this was 47 to the 30 divided by 29, this would have a remainder of, let's see, 47 divided by 29, that would be, well, I guess if you do it with respect to 58, so minus 11, and then times another minus 11, so 121 divided by 29. Yeah. Wait, did I do something wrong? Oh, wait, no, just 121. Yeah, 5. Yeah, it is a remainder of 5, but it might be easier to just say it's um, a remainder of 121. Let's see. Yeah. Yeah, remainder of 121. And then take the square root as 11. But yeah, I don't know how you can tell if it's plus or minus 11. I think I just got lucky on this one and it turned out to be minus 11. Was it 18? Oh, it was 11. Yeah, here we go. Oh, how did I go from 5 to 121? Oh, I just didn't simplify. Um, so I was like, okay, 47 divided by 29 has a remainder of negative 11. If you think about 47 is 11 less than 58. So negative 11 squared was 121. And so it's not like technically a remainder of 121, um, but you can kind of think of it that way. And the reason I did that is so that I can take the square root later. But yeah, so that's where I got the 11. Yeah, and it ended up being just 11 this time. But yeah, I haven't come up with a good way of telling whether or not it's plus or minus. Okay, 53. Looking at 53. Oh, by the way, before I go on, while we're talking about remainders, did everyone get like the really fast way of doing 42? Because this one looks kind of scary, and then you realize what you can do. Yeah, so like 3 to the 5th. Um, so 3 has a remainder of 3 when divided by 8, obviously. But then, oh, did we lose video? Oh, here we go. And then, yeah, and then 5 has a remainder of negative 3 when divided by 8. And so since these are to even or odd powers, these cancel out, so just minus 7 divided by 8, which has a remainder of 1. Okay, 53. Someone asked about 53. 8.5 is what percent less than 12.5? I would probably start off just multiplying through by a factor of by 2, just to make this a little easier. So instead it's what percent less than 17 than 25. And then what you can do here is you take the difference here. So 17 minus 25 is 8, and then divide by this 25, which gives you 32%. Yeah. I think that's like that's the easiest way to do that, especially like multiplying by the 2 to multiply by the 2 just to get the fractions out of the way. Like even if you're good at math, you'd rather not work with fractions than whole numbers. That works all the time. Yeah, if you have a percent, like a percent difference, percent less, anything like that, then multiplying through by a common factor doesn't change. Doesn't change anything. Oh wait, I think you guys tried something else. Oh, you could just do 68 and 100 also. Wait, which problem are you guys talking about? Yeah, the remainder here ended up being 11. I think we're talking about different problems right now. It's okay. All right, any suggestions? We can move to a different test if you guys feel like we're good on this one, but does anyone want to see 47? Yeah, could you go over 47? Yes, I was hoping someone would ask. Okay, yeah. This is how I usually do. This is how I usually do these problems. So, um, I usually find n first, although it's not doesn't particularly matter which one you do first. Um, but for n, you kind of like guess, sort of. It's kind of just guess and check, right? So like you know, okay. So maybe your first guess is that n equals 3, because like 8 times 3 is 24, and that's just less than 26. But then you would see that uh, this 8 times 34 over 35 is going to put you over. So maybe then you try n equals 2. Well, then you have, um, well, like 8 times 2 is 16. 8 times 34 over 35 is like kind of close to 8. Yeah, so that's like that's a reasonable guess as n equals 2. And then to find m, what I do is I take this mixed number over here and make it improper. So I get 8m plus 3 over m. And then I look at this over here, and it doesn't particularly matter what this number is. What really matters is that it's an integer, which means that this 8m plus 3 is going to have to cancel with some number divided by 35. And the easiest way to get that is if m equals 4. So 4 times 2 is 8. Okay. 4 divided by 12.5, 53. I mean, yeah, you could do that. I think this is just a little more comfortable. You can also find GCF of 104 and 26. Um, the GCF of 104 and 26, I think that's just 13. Yeah, I don't think that works for this problem. Um, Wait, I might be misunderstanding though. Okay, so this would be 8m plus 3 over m times, and then if n is 2, this would be 104 over 35 equals 26. Okay, so you're basically saying that like 104 has to cancel with m, right? So like 8m plus 3 has to cancel with 35, and 104 has to cancel with m, right? That's the idea. So 8m plus 3, that works if m equals 4. And that also works for 104, because like 104 divided by 4 is 26. Yeah. Yeah, so that works. And actually, I think that's the only value of m that would work, because 32, yeah, because you have to get, like, this has to cancel to be like a whole number. And this also has to cancel to be a whole number. There's not that many options most of the time. Okay. Yeah, that one's a little bit tricky. I used to do it a long way, and then Larry White showed me this way after state my junior year, and I was like, man, I wasted so much time, but at least I got it right. And then I went and missed like 13 problems. So I've grown since then, guys, I promise. It's on the third book. What book are you talking about? The third book? All right, I have a request to move to calculator. I have a request to move to calculator. Does anyone want me to go over any more problems on this test? I'll probably do 3 more problems on this test. The advanced number sense workbook. I guess I don't know what that is. Is that like a RAM material or like a number dojo sort of thing? You're not talking about the Brian Heath book, are you? By Anthony Taylor. Oh, that's right. You're talking about like the middle school ones. Oh yeah, I think I had that book. Yeah, I forgot about that. Yeah. Well, I didn't realize that these came up on middle school now. Okay, yeah, 71. Well, I mean, it is an inverse function, and so basically, instead of plugging in 11 for x, you plug 11 in for f of x, pretty much. Oh, they don't. Oh, it's the newer book. Oh, maybe I feel like you just had the one when I was in middle school. I don't know. Maybe I just didn't know about it. Okay, so yeah, so for 71, you just say 11 equals 5x minus 7 over 3 plus 2. So I'll subtract the 2 over and get 9. 9 times 3 is 27. 27 plus 7 is 34. So x is 34 divided by 5. Okay. Any more requests for number sense? Any estimations? What if it's like ax plus b over cx plus d? Oh, there's a way to do this. 1 second. I'm trying to remember it. There's like a formula that you can use that simplifies it. Oh yeah, here we go. In general, so if you have the inverse, okay, so if like f of x equals ax plus b over cx plus d, then the inverse of x, that's the derivative, oops. Then the inverse of x is b minus dx over cx minus a. So it's like, um, how did I remember this before? There was like a nice visual thing that I came up with. Maybe it's like, oh wait, I think I memorized it in a different way. It's like this. Yeah, I think I did it like this. So it was, yeah, dx minus b over cx minus a, and then the negative of that. So it was like you flip the a and the d. Yeah, you flip the a and the d, do subtraction instead of addition, and then it's the negative of that. So, I mean, if you want a formula, you can memorize the formula. I mean, alternatively, like just solving this set equal to f is like, I don't know, it's not way too bad. It is a little bit annoying. There's like a lot of stuff to hold in your head, but I think this would be faster if you practiced it. I'm not sure, but yeah, I think it would be faster this way if you just practiced it that way. Okay, one more and then going to calculator. Unless no one else has one. Any takers? Okay, looks like we're going to calculator. Sweet, that was nice. Okay. I just want to put it out there real quick that I got a chance to look at the other three, but I did not get a chance to look at the calculator test. So this one might be a little bit choppier than number sense, but hopefully not. Which ones do you want to look at first? I'm gonna get some scratch paper so I can work on stuff. Okay. Wait, is this district? Wait, yeah, this is district. Oops. There's region. 57 and 63. How did I know you're gonna ask 57? Okay. Let's check this one out. Okay, a farmer constructs a pen of constant. Actually, I'm gonna take this into my whiteboard. Oops. Here we go. A farmer constructs a pen of constant area, A naught, using as little fencing as possible. Okay, so this is going to be like an optimization problem. So we're going to minimize the perimeter, I'm guessing. The shape of the pen looks like this. Wow, what a diagram. This is never happened before. I'm spoiling you guys. Okay, so it looks like this. D by H rectangle. So I'm guessing this is, oh yeah, that's D. This is H. Attached to one semicircular end of diameter D. What is the ratio of the rectangle side dimensions that minimize the perimeter a number greater than 1? Okay, so we got to do here. Okay, first of all, there's basically two equations you need. You need your area equation, and you need a perimeter equation. Okay, so the area is pretty straightforward. The area of the rectangle is just h times d, and the area of the half circle is pi d squared over 4. Maybe I should be consistent in what my lettering is. Did I say pi d squared over 4? I meant pi d squared over 8. Let's see. And then the perimeter will be 2h plus d plus, oh, this is equal to a naught, by the way. 2h plus d plus 1/2 times pi d. Right, the 2h comes from here, then I have d over here, and then pi d is the circumference of a full circle, so 1/2 pi d is for this little arc over here. Okay, and we're trying to minimize this value right here. Okay. Let's get to this. Okay, this is just like a basic calculus problem, actually. He could have made this a lot more challenging. Okay. What are we minimizing, actually? Are we minimizing the perimeter? Oh, yeah. Okay, so this area is a constant. In fact, you could probably, since this is a ratio, I think you can just like decide what you want a naught to be and work from there. Yeah, so I'm just gonna like arbitrarily say that a naught is like 100. Because it's like, what's the ratio of the rectangle side dimensions? Yeah, so I'm just gonna like arbitrarily pick an a naught. So let's see. If I solve for h, I get h equals 100 minus pi d squared over 8 divided by d. And then plugging that into my perimeter equation, I get 2 times 100 minus pi d squared over 8 over d plus d plus 1/2 pi d. Okay, and this is what my perimeter is. And so if I want to maximize that, so if I wanted to maximize this, if you've taken calculus, then you know this, but for maximizations, what you do is you take the derivative with respect to what you're trying to, the derivative with respect to your variable, so this will be dp dd, the variables are a little ugly, and set that equal to 0. I don't particularly want to do the quotient rule for this, so instead I'm just going to do this on my calculator right here. It's just in front of me. And figure out what this is. Set that equal to 0. Okay, and you get a diameter of 6.776. And then once you have that, you can find the height from your equation up here. So 100, or actually, you've already solved for it right here. Oops. Okay, so 100 minus pi times 6.776 squared over 8 divided by 6.776 gives you an h of 12.1. And then what is the ratio of the rectangle side dimensions that minimizes the perimeter, a number greater than 1? So you just divide those two. So 12.1 divided by 6.776. So was the answer 1.79? Hopefully I didn't make a mistake in there. We'll see. 57. It's just 2.0. What did I do? Someone in the chat, see what I did. Are we using the fence here as well? Yeah, wait, that's 24h, 57. Yeah, just 2? What did I do? Okay, area would be hd plus pi d squared over 8. I don't think this is the mistake. I'm pretty sure I can just say that this is some constant. And the perimeter is 2h plus d plus 1/2 pi d. Yeah, that's good. Was it in here? H equals 100 minus pi d squared over 8 over d. That's good. Yeah, I think I should be able to do that without loss of generality because we're talking about the ratios here. Like the geometry is going to stay the same for a constant area, A0. Did I mess up my perimeter equation? 2 times, maybe I just typed it in my calculator wrong. Give me a second. Two times 100 minus pi d squared over 8 over d plus d plus 1/2 times pi times d. Oh, yeah, I must have just typed it in wrong. Yeah, I think you're supposed to get d as, oops, 10.58, which would then make h 5.30. Okay, yeah, so now we're good. Yeah, so you get d over h equals 2.0. Okay, yeah, sorry. Just typed in my calculator wrong. Everything I set up here was correct. I just made a little typing error. Okay, so that's 57. Does anyone have any questions about that? Hopefully that was pretty straightforward. Sorry, that makes sense? Cool. All right, let's go to 63 then. Sometimes projectile motion is just hard, but we'll see. Well, this is an interesting 65. I love the ones where it's like the infinite series. Okay, here we go. Okay, Dirk throws a penny off the Texas State Capitol building with a velocity of 28 miles per hour and a release angle of 64 degrees relative to the horizontal. It hits the ground in 5.63 seconds. What is the capital elevation? 65 was unusually easy for its placement. Yeah, actually, like it looks cool, but I think this one's actually pretty straightforward. Oh yeah, it even gives you like the ratio. Oh yeah, that's actually, I wasn't expecting him to give you the ratio. Okay, so let's see, what variables do we have? We know the initial velocity is 28 miles per hour. I'm going to really quickly convert that to feet per second just because I know the acceleration due to gravity in feet per second squared and not in miles per hour squared. So my initial velocity is 41.07 feet per second. And for that, you use the conversion 22 feet per second is 15 miles per hour. Number sense conversion coming in clutch there. Let's see. Our release angle is 64 degrees, and it hits the ground in 5.63 seconds. Okay, so this is like a kinematics question. We do everything in the y direction. So our velocity in the y direction will be our velocity here, which is 41.07. And then if the release velocity is 64 degrees, then our Vy will be our V naught times the sine of 64 degrees. Now, my calculator was in degrees, this would give me the right answer. 36.91 feet per second. Okay, we know the time of flight was 5.63 seconds. We know acceleration due to gravity is negative 32.174 feet per second squared. And finally, oh, okay, so we have three variables. We just need the capital's elevation. So now we're just looking for delta y. Okay, now we're going back to physics 1. Let's see if I can remember what this formula is. Oh, that's right. Delta y equals v naught t plus 1/2, well, I guess this is y, plus 1/2 ay t squared. And so you just plug in all of your stuff, all of your variables. You should get 302 feet. Pretty tall. Let's double check that. Yeah, 302 feet. That's what you get from the UT physics major, I guess. No, I'm just kidding. But yeah, that's how you do those problems. It's usually just some variation on kinematics. That's one that, you know, in the big calculator, like stated in geometry practice one, you have there's like the two sections. One of them is like the acceleration problems, and the other ones are like the trajectory problems. There's not a whole lot of the trajectory problems. In fact, most of those are like pretty hard, but the acceleration ones have more problems like this. There's a lot more of them, and they're like on the easier side, so they help you just like speed up and get used to the kind of stuff that they like to ask. Okay, so we did 57 and 63. How are the other geometries that are typically hard? Squares and four identical rectangles. Oh, you just use the symmetry there. Those areas are equal. This is funny. That's a funny question to have on calculator. What else? I bet some of these are hard. Just overflow, sinusoidal regression sort of stuff. It takes a second. I'm sure one of you has a program for this, but I don't know. I kind of ended up just doing it. Identical rectangular solids. What is this? Oh, AB. That's a weird diagram to look at. I feel like this calculator test wasn't too bad. I mean, it's hard to tell when you don't actually take it, but how many 8-foot long beach towels are needed to cover the same area as 25 5-foot beach towels? Okay. Got right triangle. Oh, this is actually just like a SOHCAHTOA problem. Here we go. What's the length of the line segment? Okay, just solve those points. Do you guys have any more questions about calculator? I'm kind of just rambling right now. Uh, 36 and 37, when you first read them, it's not super obvious what to do, but usually how 36 and 37 go. Right, isosceles triangle prism. What was the SD problem on this test? You want to look at like how to find the SDs on this problem? The world land speed record was set by Andy Green. Hold on. Oh wait, this is 30 has bad diagrams. I don't know. This one was just 6. Even it was just 6. Like that's the answer. Oh, yeah. I see you. You always have to read the top. Yeah, that. In fact, when you go to solve one of these problems, that's like the first thing that I would always do because it happened a couple times where I didn't read it and then got messed up. But yeah, I'll always read this. But yeah, you're right. Although it does say volume, so like it would be pretty. Oh, 6 SDs. Oh, oops. Other one. Oh, this problem here. Yeah, I think it's just 6. There was a tapered candles question. Or was it, did I miss that one? Oh, 28. Oh, these ones are so annoying because you have to find like thrust and volumes. Honestly, tapered candles, maybe this is an unpopular opinion, but they always like ask the same exact question with the tapered candles. This might be worth making a program for, honestly. Because like if they seem to ask it like not that often, but whenever they do ask it, it's like always the same exact question. That might be one that's worth making a program for. I don't know. You guys can decide. If he asked it on region, he probably won't ask it on state, but I don't know. Maybe he will. You got to run 321.96 for height. You're talking about on the projectile motion problem? Yeah, I agree. Just by like skimming this, it doesn't seem way too difficult. What was the highest score on this test? Probably like 329. Or did someone break through to the 330s? 327. Yeah. Is that Brennan? Oh, Eric Lee? Wow. He's improved in calculator a lot. Brennan 313. Okay. Maybe that was just nerves. I feel like Brennan has more than a 313 out of this test, but I don't know. Stuff can happen. Okay. Were there any other questions on this that anyone wants me to go over? Or do you want to go to math? Because I hear math was pretty hard. He was locked in. I bet he was. Sometimes stuff just happens though. Yeah, is there anything else on this test you want to look at? Anything that you're like wondering if there's a quicker way to do it? Or we can just go to math. Or we can go to physics. If you guys want to go to physics, that'd be cool. Alright, if you guys don't really mind either way, then I guess I'll go to math. And if you have a question on calculator, we can just come back to it. Alright, headed to region mathematics. What was tricky on this test, guys? A lot of time sinks. Yeah, I get that. Okay, the population one is for 47. Oh, is this like logistic growth or something? Oh yeah, here we go. Yeah, these ones kind of just take a while. Okay, so in April, researchers from Texas A&M found that the Lake Marvin trout population was 0. They believe the lake could support no more than 5,000 trout. Okay, that's like a key thing. So that means that our limiting population is 5,000. On May 1st, 1,000 trout were released into the lake. So P at T equals 0 equals 1,000. They believe the increase of the trout population after T weeks can be modeled by this logistic differential equation. Okay, sweet. Okay, how long after May 1st, this is a two-parter, right? Yeah. How long after May 1st will the trout population be growing the fastest? Okay, I don't know of a quicker way to do this than to just solve the differential equation and then take like second derivative set equal to 0. There might be a faster way than doing that. Although you can tell immediately that like the max growth will happen at p equals 2500. So maybe if you just like solve the differential equation and like solve for when p equals 2500, that would be quicker than taking two derivatives. Actually, yeah, it definitely would be. But okay, let's look at how to do this. So in general, if you have a logistic differential equation in this form, this is probably a good thing to memorize, by the way. Because like you can solve the differential equation just by hand, but it gets tricky. So if you have something dp dt equals kp times 1 minus p over L, notice that's not the same form we have here, so we'll have to change it around a little bit. Then the solution is p of t equals the carrying capacity, or the limiting population, whatever you want to call it. I just don't like to use C when I do calculus because, I mean, obvious reasons. Equals 1 plus A times E to the minus KT. Okay, so the first thing we have to do is we have to actually get this into this kind of form, like what it gives us, this into this form. I always forget if you guys can see the cursor on my screen. 1 plus, oh yeah, that's what I'm going to do. Right now we just have to solve for when A, we have to figure out what A is. But yeah, what Agnew was saying is, yeah, it's going to be growing the fastest when you're at half of carrying capacity. And you can tell that because like this differential is just a parabola. You see it's just like P times another factor times P. And so like the peak is going to be halfway between the roots. But yeah, so if you want to find A, oh yeah, first you have to get it into this form, which you can do by like dividing by 1,000 in the parentheses and dividing by 5,000 in the parentheses, multiplying by 5,000 outside. And so you would get, let's see, 0.0, make the zeros right there, 0.00003 times 5,000 would be, so that will be 0.15 p times 1 minus p over 5,000. And so p of t would be 5,000 over 1 plus a e to the minus 0.15 t. These k's are the same, by the way. That's why I set it up this way. And then you have to solve for a, which you can do because you have this initial data right here, since you have p of 0 equals 1,000. So you can say 1,000 equals 5,000 divided by 1 plus a times e to the 0. So that's just 1, so a is going to be 4. So our logistic equation will be 5,000 over 1 plus 4e to the minus 0.15 t. And then like we were saying before, you can either take the second derivative of this and set it equal to 0, or you can notice that the population will be growing the fastest at p equals 2,500. So just plug 2,500 into here and solve for t, which gives you 9.2 weeks. I think that's right. 46 is C. Nice. So yeah, I mean that can take a second, but notice that like now that we have that, 47 is super easy. actually. Oh wait, it does say 2 weeks. Yeah, never mind. Yeah, but now that we have this equation, it's super easy to do 47 because you just plug in 25 in for t. So you get 4973. What did I do wrong? Oh, I can't type. 4570. There we go. Okay, did that make sense? Hopefully that made sense. Does everyone see why I was able to just say 2500 is where it's going to be growing the fastest? Yeah, don't worry about the caps lock. That's fine. Yeah, because it occurs with half carrying capacity. Right. It's because like this right here, this dp over dt, you're just basically trying to make this as large as possible. And if you notice, this over here is just a parabola, right? It has roots at p equals 0 and p equals 5000. And so for a parabola, the vertex is halfway in between the roots. So p is going to be 2500. If you really didn't trust that, you could like technically take the derivative of this again and set equal to 0. But that's like the intuition behind it. You memorize ln c over lk. Oh, okay. I guess that's true. Will that just give you the answer? I'm guessing you're using C as, wait, what are you using C as? Oh, your C is my A. Right. I'm not sure if that works. I think we're calling our variables different things. But yeah, you could definitely like simplify this down if you wanted to just if you only wanted to worry about a specific kind of problem. But yeah, that's how you do it in general. Any questions about other parts of this test? How is the stats and calculus on this test? Or is that not the slow part? Montana Institute of Technology. That's crazy. Will be another sinusoidal regression. It's kind of a fun problem. 29. Not too hard, but maybe something you haven't seen before. Inverse functions. Oh, 20 was interesting. I wonder how you guys did number 20. Um, Honestly, the quickest way to do this problem might just be to guess and check, especially if you have an inspire that will do factoring. But off the top of my head, I'm not seeing a super quick way of solving this. Synthetic division. Oh, duh. Obviously. Yeah. I completely forgot that existed. Thanks for that. Yeah, synthetic division. So if 7 is a 0, then I should be able to. Oh, yeah, I'm just a moron. That's all right. Yeah, okay. Obviously, if 7 is a 0, then I should just be able to plug in 7 and get the answer that way. I don't know how I didn't see that. Yeah, so I'm pretty sure K ended up being 9. But yeah, yeah, you're totally right. That's funny. Okay. Can solve a logistic equation, but I guess algebra 1 is just too advanced. Hmm. This up here, like with the, I don't know about you guys, but these problems kind of just annoy me. Where it's like they give you these points and you have to find like a bunch of other things with the points. I don't know. For some reason, that was just like always a time sink for me. I found, wait, which problem is that? The area of the triangle bounded by secants. Oh, this one? Yeah. I wonder if there's an easy way to do this. 15, 16. Point O is the center of the circle. DO is 12. Okay, so our radius is 12. DB is 60. So EB is 36. BA is tangent at a point A. BC. Okay, cool. Find DCB. DCB. Hmm. Okay. Well, that's a right angle. And okay, so finding the area of this triangle of OCB is pretty easy. Say 15. What did I say? Did I say something wrong? Oh yeah. Oh, you mean problem 15? Yeah. Um, yeah. So OCB isn't bad because this is just a right triangle, right? Um, Hypotenuse of 48, radius of 12. So just do Pythagorean theorem and then yeah. So the area of that is like 279. And then for DOC, I guess you have to find this angle somehow. Oh, I guess you just find this angle, which would be inverse cosine of 12 over 48 and 180 minus that. And then you do 1/2 AB sine C. So the area of that triangle would be 349. Yeah. Yeah. Okay, so to find this angle, I just used this right triangle here. And it's like, okay, that's 180 minus whatever this angle is. And then the area, yeah, I can see why this would be a time sink. Find the area of the region inside AOB, but outside sector AOE. Okay, well, I mean, this triangle is going to be the same. AOB and OCB will be equal. And then you can find the area of the sector relatively easily because you know what that angle is because it's the same as the one we found earlier because it's like 75.5. So pi times 12 squared times that over 360, 249 minus that. So 254. Oops, what did I do? Oh, wait, no, it's not the full triangle. It's just the one part of the triangle. 184? Yeah. Okay. Any other problems you guys want to look at? How was the stats on here? I might be a little rusty on stats because I literally only learned it for UIL. I have not used stats since I've started college. I've used probability, but I haven't used stats. Okay. Oops. There we go. What else on here do you want to look at? Does everyone know the discriminant rules for number 30? Like how to tell what kind of conic this is? So you can use like the discriminant just like for a quadratic, like b squared minus 4ac, except now b is the xy term, the a is the x squared term, and the c is the y squared term. So it's like 36 minus 4 times 1 times 25. And if that's less than 0, I believe that's an ellipse. Oh, I can just think it's a hyperbola. You might be right. Um, Actually, no, it's definitely an ellipse, because if you take like a circle, like if I have like x squared plus y squared equals 1, then b squared minus 4ac is going to be less than 0. Yeah, so that's definitely an ellipse. Yeah, yeah, it's a good way of remembering it, is to just like take the easiest case that you can think of. Let's see, what else on here? Did you guys remember the polar arc length formula? Because I didn't. Like, I don't know. It's just stuff like that it's hard for me to remember. 6 minus 6 sine theta. I think this is a cardioid, right? Because the 6 and the 6 are the same. And it's just theta. It's not like something multiplied by theta. I did square root of 1 plus dr d theta squared. I think it's square root of r squared plus dr d theta squared. If I'm not wrong. I think that's what I did when I was looking at this earlier. Yeah, I think you're thinking of like the parametric. No, not the parametric. Just like the regular. Like it's 1 plus y prime squared. Also, this is insane. Suppose 25% of students at Latexo plan to attend Harvard. For that, you just graph the curve. Oh, yes, for the one up here, let's just like identify the polar region. Yeah. I would normally do that because I always forget, like, if these aren't equal, it's like, if it's less than 1, then it's a limacon. If it's greater than 1, it's like it's like limacon with the inner loop, and then like if it's greater than 1, it's like a limacon with like a dimpled limacon, I think is what it's called, and then if it's greater than 2, it's a convex limacon, a limason. I actually don't know how to say it. None of these options. Although a cardioid is a kind of limacon, just with the 0, 0. Not 0, 0. Where the ratio is 1. What problems on here were slow? Because you said there was like a lot of time sinks on here. Do you guys know the formula for 45? If you take the derivative of an inverse function, like f minus 1 prime of a is the same thing as 1 over f prime of the inverse of a, like that. Usually when he gives you these, he doesn't make it so you can find the inverse. Like, I'm not even sure if this, wait, I mean, it probably has an inverse, it's just probably not a nice one, if I had to guess. Yeah, it's just really ugly. Wow, that's crazy. Yeah, I guess the trapezoidal sum would take time. Yeah. If everyone's good, we can go ahead and end the stream now. Unless you guys have more questions, or you wanna move to physics instead. 49 was tricky. Let's see. Consider the region M in the first quadrant bounded by these and the y-axis. The vertical line x equals c divides M into two regions. Oh yeah. Yeah, I guess you do have to bound that vertically, right? I usually just end up graphing these if I see a problem like this, just because they can be kind of tricky to visualize. Yeah, and the y-axis. Yeah, that is a little bit. Yeah, I think he's asked something similar to this before. Um, Maybe I'm wrong, but I think he has asked something like this before. Yeah, the perimeter of one leaf of the rose curve, that's the one with the polar arc length. Okay. Do you guys want to go to physics, or are there any more questions you guys have on math? By the way, shout out Mr. Cantu. Okay. I'm not getting a whole lot of feedback right now, but I don't know. Have I answered all of the questions that you guys have? I can see how this math test would be slow. There was a pretty steep drop off in scores from district. Okay. Well, if that's all you guys want to look at, then that's cool. Um, this was fun. I hope you guys learned something. And just text me in the Discord or something like that. In the Discord if you want to see something like this on Saturday as well. Or if you guys think that pretty much got everything down, that's cool too. But yeah, I hope you learned something. Oh yeah, you're welcome. I hope you learned something, and yeah, if you want to see this later, we can definitely do it again. I only have one more final on Monday, and I'm not worried about it. But by Saturday, I'll definitely be able to be more flexible with this stuff. Well, good luck at state, everybody, and yeah, this was fun. See ya.